Hi guys, welcome back to Data Every Day. Today we're looking at a data set of bakery sales. Um, so basically, this guy who uploaded this works part-time at a small bakery in Korea, and he went through the trouble of compiling a data set of different days of sale. Actually, each one of these is a customer receipt. You could think of the amount for the sale, the day that it was on, the timestamp, and then what they bought. So we have one hot encoded. Actually, not exactly one hot. They're count columns for each per object that someone bought. So if they bought two of something, you'll have a two. But we have one column for each item on the menu, and you can see we have that until the end. So let's hop into the notebook. What we're going to try to do is actually predict whether a given sale whether a given day's performance was on a weekend or not. So it's a bit of a strange task. I'm not sure how practically useful this task would be, but I thought it'd be interesting to do some sort of advanced data manipulation to get this working. So let's go ahead and import all the imports. I'm using NumPy and Pandas for working with the data. For visualization, I'm going to use PyPlot and Seaborn. For pre-processing, we'll use the train test split function and standard scalar from sklearn. Our model today will just be logistic regression, and we'll see a confusion matrix and classification report to analyze the model afterwards. And that is from sklearn. So let's go ahead and import all of that and load in the data using pandas.read CSV. We grab the file path up here. Let me just zoom in on this. So over here, the CSV we're going to be using is the bakerysales.csv. So I'm going to copy the file path, paste it in here, and we can take a look. Alright, so the missing values really should just be zeros. Yeah, so they're blank, but it means that that was not bought by this particular customer. So let me try to clarify what we're trying to do here. I want to sort of aggregate the data in such a way that each record represents the sum of all purchases made on a given day, and then try to predict if that day is a weekend or not. So we're going to need to do many steps to get this data set in order. We can get a little more information about the data frame here with data.info. What's interesting here, I see I'm actually really, if you guys know why this is, please I'd love to know. It says we had 0 non-nulls in this column, but if we look at the column and do .isNA and sum over it, we get 2,654 null values. So I'm wondering why. Oh, it's non-null. Okay, I understand. So it's fully null. All right, so these two columns are not going to be useful because they're all the same value in there. Okay. Or a lack of a value, I should say. So let's start pre-processing. Okay, so I'm going to create a function called preprocessinputs. And this is going to take in a data frame, make a copy of the data frame, and return the data frame. So this is just going to give us our fresh copy of the data set that we're going to use to do the pre-processing on. I'm going to call that x. Right now it's just a copy. So the first thing I'm going to do is drop the place column. And there aren't actually too many missing values here. But if we look at the unique values in here, you can see, each value is a different place. I think it's a place where the customer comes from. That's what it says here. Or a customer's place. So I'm not sure exactly. But basically, because we're going to be aggregating the data across all records, we're going to have multiple places. So we are not going to use this. Now we could one-hot encode it maybe, but I think it just makes sense to drop this for our purposes. So drop place column. That's going to be df equals df.drop place axis 1 for the column axis. Alright, so that's gone, and that was a pretty simple step. Now what I'd like to do is deal with these missing values. So I know a lot of these missing values should be encoded as zeros. If we get x.isNA dot sum, you can see the total number in each column. Now everything for the menu item features, so everything up to here, these missing values need to be encoded as 0. And that's because that missing value here actually means there were 0 of them purchased. However, these first 3 columns, a missing value here does not mean that means it should not be encoded as 0. Missing value here might actually be missing data. In fact, it looks like we might have some fully missing rows. So what we're going to do is anytime we see a missing value in any of these 3 columns, we're going to drop that row. And after that, we should only have missing values in all of these ones. Alright, so let's drop rows with missing, we'll say without sales or date information. So to do this, what I'm going to do is take just these 3 columns. We can do that with a double bracket to return a data frame containing a list of the columns we want in the data frame. So it's going to slice the data frame like that. So just get these ones. And then we can take the is and a matrix of this. And then we can use the any function over axis 1 to look at each row across axis 1. And if any of them are true, we'll return true. So this will return a single series where true means there was at least one missing value in that row between these 3 columns. And we can now use this true-false series as an indexer for x. So let's index x at this with this Boolean series. And we'll get just the rows that have missing values in the first 3 columns. And as you can see, these actually look like missing rows. The only exception being this one, which has a single value. So these are useless. We're going to drop all of these. So we can get the indices for them with .index. We're going to drop these indices. So let's put that in here, and I'll just change x to df. And then we'll say that is called missing rows. And we'll say df equals df.drop missing rows. And axis is 0 this time, since it's rows we're dropping. And since we are dropping rows, let's reset the index. And I'm including drop equals true so the old indices don't become a new column. Now we will fill the remaining missing values with 0. So if we run that now, look at x. Our only missing values now are going to be in these columns. We can double check that here. We have 0 in the first 3, and all these should be encoded as 0 because it actually means there are none of those bought. So we can fill the whole data frame since we know only these types of missing values remain. So df equals df.fillNA 0. Now I'll just fill all missing values in the data frame with 0. Okay, so now you can see the NANs have been encoded as 0. And at this time, we want to aggregate the data. So all of these are count columns. So if we sum over rows, we'll be able to count up how many of a given menu item were bought on a given day. So we want to group by the day. We're going to use the group by function for this. Group by basically is like x.groupBy, and we group by total. No, let's do day of week. Then it'll create a group by object where each element in the group. We can't do that. Let's do this. Let's take the mean over all group by objects. You can see this is each group. So a group is really a slice of the data frame. Oh, can we do it like this? No, not. Okay. Oh, wait, what about this? I'm not sure. I haven't tried indexing it like this. No, it's not going to work. Alright, anyway, let's just look at the mean then. So this is taking the mean for each group and for every column. Oh, I also want to point out these guys. These columns we saw have they're all missing values. Let's actually drop these columns. They only have one value in the whole column, so it's not worth keeping them on. So up here, drop single valued columns. And that's df equals df.drop. These two from axis 1. Okay. All right. So we've grouped by day of the week, and now we're taking the mean for each group. So this is the mean over all rows in that group for each group. Now, I wish we could see the groups. There must be a way to do this. Let me see if we can just look this up real quick. I'll just copy that. Okay, here's group by. We can definitely iterate through it. Oh, dot groups. Let's try that. Dot groups. Oh no, that's okay. These are the indices for the group. You can see each group has indices pointing to elements of the data frame that have that value for the group. Get group. Okay. Well, we can definitely do this. For group in the group by object, print the group. And you can see this is, alright, so this is the best way we can really visualize it. So each one of these is a group. So this is the group for Friday. Down here we have the group for Monday. And you can see we just have different rows of the data frame. So when we take the mean over it, like this, we're taking the mean over all of the rows for a given group. And what's wrong? Invalids. Oh, I left that on. Alright, so each group has a mean for every column. I hope this makes sense. So if we take the sum, then we're counting up the number of each menu item that was bought on a given day of the week. So what we want to do is do this, count up the amount bought, but not for a given day of the week, but rather a given date. So on a given day, like an actual day, how many of each was bought, and then what was the full total price, money earned by the bakery. So the only issue is these datetime objects, or the string, contains time information. So they're all going to be unique. What I want to do is remove the time information so that we can group by the day. So I'm actually going to create a function here. I'll call it drop time information. And this is going to be a function I'm applying to a string. So I'm just passing in x, which is going to be our string. And we're going to create a new string, which just takes x and applies the transformation to it. So let's say x is this one. We want to strip the time information off this and return a string without it. Now, oh wait. Okay, now there's a one way to do this might be trying to maybe use regular expressions to remove it. In this case, let's actually do that. I like the regular expression idea. So let's look at regex 101, which is a nice site for testing out regular expressions. We grab the string and put it into the test string area, and now we're going to try. We don't need the quotes. We're going to try to grab all of the characters that I highlighted. So we don't want the space and the time. So we can do this by saying, let's look at the start of the line. So the caret means start of line. Then any digit characters followed by a hyphen, followed by any digit characters, followed by a hyphen, followed by any digit characters. And that should do it. So let's grab that, and I'll just put it here for the time being. I'm putting in a raw string. Okay, so I have to import regex. So import re, and we can use the Well, there's a few ways to do this. One way would be use the search function. You know, it might be a better way. Instead of targeting this, we can target the end and then substitute it with an empty string. So instead, let's do this. We'll use a $sign to mean end of the string, and then any digits followed by a colon followed by any digits. And that should get the time. We also want a space. So that whole regular expression should take off the end. And this will work whether or not it's a single digit hour, or even if you have multiple digits, it wouldn't work. Yeah, it would work. Alright, so let's use this one instead. And our string will basically be regx.sub. So re.sub allows us to substitute a part of a string with another string and substitute the part of the string that matches the pattern that we pass in. So let's pass in the pattern, and we want to apply this substitution to x, and we want to substitute the part of x that matches this description with the empty string. So maybe we don't even have to call it new string. Let's just return this. And if I call drop time information on this now, okay, that did not work. I think maybe I switched these. There we go. Okay. So we're replacing anything that matches this with the empty string, and we're applying that to x. So I don't even have to call this a function anymore. The reason I did this is because I was going to do it with datetime conversion. But that's actually, this is a better way to do it with regular expressions. So here's what we'll do. Remove time information from datetime column. So we just take the datetime column and apply a function. And I was going to pass in this function name, but instead we can just pass in this, because that's the whole function. Except we have to make it a lambda. So for a given x, we'll apply this function to x. And let's store the result back into datetime. So this is just stripping off the time features, the time information. And now you can see we just have the strings corresponding to the year, month, and day. So now we can aggregate over the datetime. Over the date, I should say. It's not really a time anymore. So only thing is, if we aggregate, if we take the sum, it will actually automatically drop the day of the week column. The reason is you can't add these together. They're categorical. So it just drops anything that isn't numeric when you use the sum function. So to work around this, because I do need to know what day of a week a given date was, since that's what we're trying to predict, if it was a weekend or not. To work around this, I'm going to just save these two columns as they are to provide us with a mapping for later, so we can always see what day of the week a given date was. So let's call that day mapping. I'll save a copy of the date, time, and day of week columns, and I'll call it day mapping. So that's just going to be the slice of the data frame containing date, time, and day of week. And we'll make a copy. Now we will group. So we're going to group by date. So currently x looks like this. We want to group by datetime by the datetime column. So df equals df.groupBy, as I showed before. We're grouping by date time. I'm also going to include as index equals false. What that will do is you see right here, this became the index. If we just include as index equals false, then it will stay on as a column, which I would prefer. So as index equals false, and then we take the sum over all groups, and that's going to be the new data frame. So if we run this now, does that work? Why isn't this working? df.groupBy.sum. Oh yeah, it did work. Oh, okay. Sorry. This is correct. So we have now 250 rows, significantly fewer rows, and also why I feel like this might not be such a good task because we now have very little data to work with. Um, but you can see the total revenue that was made on a given day, along with how many of each item was bought on that day. So we're hoping that maybe on the weekend, either people are buying more or less, so we might be able to predict if a given day is a weekend. Only thing is now we don't have access to the day of the week column, so that's why we saved this mapping that we can use to now reapply the days of the week. So let's recreate the day of week column. I'll say values from day mapping. So, okay, that's interesting. Okay, so what we're going to do is take the day mapping. So I'll take the day mapping out, and I'll sort of I'll create an environment variable for it. This will just change to x, not in index. Oh yeah, yeah. Okay, so we have to undo this one. Let's undo the group. Make x, then create the group mapping. The day mapping. Then re-enable this, run this, and check it out. Alright, so here's x, and here's our day mapping, which is just it contains the mappings for each date and what day it was. So we can now use the day mapping to plug in the proper days of the week based on the date. So we're going to map the date to the day. To do this, we'll take the day mapping, just take the datetime column of it, so that's just this column, and ask is it equal to a given date x. So let's use this as an example. This will give us a true whenever we have that date available to us. We could then use this true false to index within day mapping, like this. And you can now see the records that have that date, and the mapping is therefore contained within this data frame. So we want to get this value, and we know these will always be the same. We'll always have a row, so depending on how many things are bought on a day, okay, let's grab like this one. We might have a different number. Whoops. But we'll okay, 2 again. But we could have any number of these, but there will always be the same day of the week and the same date. So we don't really care about the order of them. We just want the first Monday that shows up. So we can use .values to get it back as a NumPy array, so we don't have to worry about indices. And then just get the first record and get the second value. And that should give us back what we want. So this can work for a given date. We take in a date, any old date, we grab one, paste it in here, and it will tell us what day of the week it was. So let's use this in our function. We're going to create a new column called day. That's going to be this thing. Sorry, it's going to be date time. It's going to be the date time column with a function applied to it that is this thing. Except the date that we're passing in is just any old x that for every date in the datetime column. So if we run this again, if we look at x, you should now see at the end, no, that didn't work. Oh, I didn't run this. Okay. If we look at x now, you can see we have the day at the end based on the date. Alright, now we have the days back on for a given workday. We now no longer need the datetime column. In fact, it would be cheating to use the datetime column since it contains information about the target. The target was actually sort of created from the date, so we have to remove that. So drop the datetime column with df equals df.drop datetime from axis 1. Alright, let me get this line of code up here. Alright, so here we go. Oh, what? It didn't drop? Why isn't it dropping? Oh, there we go. Okay. All right, and here's the data set. Last thing we have to do is change the day column to be a weekend column. So let's change day column to be is weekend. So we'll create this new column is weekend, and this is just going to be the day column with a function applied that returns for a given x, which will be a given day of the week, will be weekend if x is Saturday or x is Sunday. Otherwise, we'll call it workday. So now you can see we have a workday and a weekend whenever it's Saturday or Sunday. So this is our class column. And now we do have to remove the day column since this again was created from the day column. So df equals df.drop day from axis 1. All right, and we're about ready to train. We now have a data set that works for a model. We have feature data, the total revenue from a single day, and the number of each item that was bought, and then our label, whether it was a workday or a weekend. So I don't know how well this model will perform. We're going to try to predict whether a given day was a weekend based on the performance of the day. So we can delete all this stuff now. And we can now do some simple typical pre-processing. We're going to split the data frame into x and y. So y is what we're trying to predict, so that's the is weekend column. And x is all the rest of the data, so we drop it over here from axis 1. Then we do our train test split. That's x train, x test, y train, and y test. We're splitting x and y with a train size of 70%, keeping shuffle equals true on, and a random state of 1. Alright, and let's return these 4 sets of the data. Get them back over here, take a look at x train. So we now have split the data set into 4 sets. The y's are our label column, the x train is our feature data. Last thing to do would be to scale x. So I'm going to create a scalar. This is a standard scalar. And we're going to fit the scalar just to the train set. We want to pretend we don't have access to the test set when we're doing the pre-processing. So then we'll transform both the train and test set using that fit. But this returns a numpy array. So if I run this, you'll see we get a numpy array. So I want to see it as a data frame. So we'll turn it back into a data frame after. And we'll keep the indices as they were and the column names as they were. So then we'll copy that over and do the same thing for xtest. Alright, we're done. This is our input data. These are our labels. Let's train. Now let's see the value counts of these. The class distribution. Alright, so we have about twice as many workdays as we do weekends. So, training. Training will be very simple. We'll just create a logistic regression model and fit it to the train set. And we'll get some results. So let's print out the accuracy for the test set. I will display it to 2 decimal places as a percentage and format it. In order to get it, we'll do model.score xtest ytest. So the score function, in the case of a classification model, will return the accuracy value. And since we want to see it as a percentage, I'll multiply it by 100. And we get an accuracy of about 57%. Alright, let me see something. Give me 1 second. Alright, don't worry about it, I was just double checking something. Alright, so we got a very low accuracy. Oh, not a great accuracy. But we also have to keep in mind that the test set we're working with is only 75 examples in it. In addition, the train set we're working with, train, has only 174 examples in it. So we both have the problem of having very little data for the model to learn from, but also that the test set may not be representative of the train set, and the train set may not be representative of the test set because there's such a small sample size. So we can also get a bit of information about the results using a confusion matrix. So let's do that. First, we need some predictions. So that's going to be called ypred. We'll get that from model.predict on the test set xtest. Then we'll create our confusion matrix using confusion matrix function from sklearn. Pass in ytest, ypred, and we'll specify the labels. So this allows us to choose the ordering in which we see the labels show up. So let's put workday first and weekend second, since weekend is the positive class. Alright, and then we'll do the same thing for the classification report, which is we'll call CLR, and that'll be a classification report from sklearn. Same arguments we're passing in. Alright, then we'll plot the confusion matrix. So we'll create a new pie-plot figure with a figure size of 6 by 6, since it's only a 2 by 2 confusion matrix. And then use a seaborne heat map to plot it. We pass in CM, turn on annotations, use format equals G so we get it as integers instead of scientific notation. Give it a color map of blues, turn off the color bar, and then we'll set the tick marks. So ticks is the spacing. We'll just do 0.5, 1.5. That'll line up with the middles of each box. And the labels will be the same as right here. Now we'll do exactly the same thing for the Y ticks. And let's give it some axis labels. The X label will be predicted, and the Y label will be actual. And we will see, we'll give it a title of confusion matrix and show it. Last thing I want to do is print out a classification report. So I'll say print classification report, then I'll just put some hyphens. And another new line, and then pass in CLR. X has 22 features per sample, expecting 24. Xtest has 22 columns. Xtrain has 22 columns. What's wrong here? It's a problem with this. Model.predict on xtest is giving us an issue. What about on xtrain? It's not even working on xtrain. Do we need to retrain this? Oh, did I oh, okay, never mind. That was from when I was messing around with it before. Alright, so let's see this. Here's our confusion matrix, and you can see we're not really doing so well, really doing quite badly. We have very, very low precision and recall for the weekend class. We're doing okay at classifying workdays, but we're also making a lot of misclassifications. We're both predicting too many weekends as workdays, which is what this is, and we're predicting too many workdays as weekends, which is what this is. So our true positives, which would be the predicting weekends as weekends, is very low. It's the lowest value in all of this. So the precision, let's look at weekend. The precision score is saying out of all of our predictions for weekend, how many did we get correct? Well, 32%. For the recall saying out of all the actual weekend examples, how many did we predict correctly? Only 41%. And the F1 score is a combination of the two. So you can see overall we're really not doing so well. However, I really picked this task not so much for the model's performance, but just for like the pre-processing because this was a bit of a challenge to get this data set into a form that allowed us to do this kind of prediction. So that will sum up today's video. Thank you so much for watching. I hope you enjoyed it. If you did, make sure to subscribe and hit the bell for more content, and leave any comments you have in the section below. I'll see you guys tomorrow. Have a fantastic day.